Well, good afternoon, everyone. My name's Carl Larsen from RMCG, and today, managing salinity in vegetable crops. We've got a great lineup of guest speakers for you, all broadcasting out of Devonport in Tasmania, but I know a lot of you are joining us from right around the country and a few international guests as well. So welcome. We do have a pretty jam-packed hour to get through at the moment, and really this topic has been in response to what we've been hearing and seeing out on the ground around the main vegetable growing regions in Australia. And we've got a couple of really good topics to set the scene and also get into some of the details. So we're going to start firstly with the lay of the land, why salinity is important, and Dr. Doris Blaesing from RMCG and Bruce Scott from Muir Sons are going to take us through that before we pass over to Julie Finnigan from Servag to take us through getting it right, good salinity management practices. And there's going to be the opportunity for it to be a bit more interactive with the panel there all in the one location than some of the usual webinars, which is great. And at the end, Bruce is going to kind of take us through a bit of a deep dive into the relationship between crop nutrition and salinity as well. So before we do get started, just a little bit of housekeeping. If this is the first session that you've joined and GoTo webinar is completely new to you, fear not, it is relatively straightforward and user-friendly. So you'll see on the control panel, there's a number of boxes there around attendees. You can see who else is on the line. But the two important things I wanted to highlight for you was, one, there's a handouts panel there that's got a couple of handouts for you to download and take away during the session, and we'll talk to those a little bit more later. I think most importantly is the chance for you to interact and engage with our presenters, which is in the questions panel. So if you click on that and type a question, that comes directly through to me during the session, and we can put those to the speakers. We just try and keep everyone on mute to minimise background noise so everyone can hear us. Before I do hand over to our first speaker and get things going, just a little bit of a snapshot of the Soil Wealth and ICP project, which this webinar is being delivered by today. The focus of this project is really on extending existing research information on soil management and plant health in the Australian vegetable industry. It's been going for a number of years now. Phase 1 concluded in 2017 and kicked off with phase 2, which is running through to 2022. So all up 8 years of delivery. There's a number of different mechanisms that we're using to get information out there, like demonstration sites, webinars like this, but also things like farm walks and other comms channels like the website and e-newsletters as well. So with that said, I'd like to hand over to Doris Blaesing and Bruce Scott to take us through the introduction. And Julie, I might switch over to your presentation for that to happen. So I'll just switch screens there. And Doris and Bruce, over to you to take us through the first part. Thanks.
Yes, so Carl, you posed the question, why is salinity important and what is it? Well, starting with why is salinity important is because it does affect crops negatively. So it takes stuff off the bottom line. And salinity, we have all seen our travels. So even though we're in Devonport, we all get around the country quite a bit, and certainly seen salinity in work in South Australia. And Bruce, you've been traveling probably the most actually in your quest to beat salinity. So what's the observation?
I think every state that I've been in has got some issue with salinity, so it's become a greater issue over the past few years. And I guess at the moment we've got the large areas of Australia vegetable industry that's suffering from drought conditions, and that seems to exacerbate the whole salinity issue. So it's Australia-wide, and it's having an impact, as you say, on the bottom line, the production and the quality, particularly of the crops.
Yeah. And I've been finding people trying to look for information on managing salinity in vegetable crops, and there's not much one can really find. That's one reason why we are here and have this webinar. The causes of salinity seem to be quite varied. I mean, in WI, I know about ingression of seawater.
Yeah, I think the underlying geology of the place can have some salinity that's been there for a long time, or might have started out as a sodic soil, and then you've got the salinity attached on top. So the quality of the water has become a real big issue, and especially during the drought years where the Murray-Darling system gets saltier and saltier as the years go by, until you get some decent flushing rains. There's an ever increasing problem that we've got to deal with, and trying to manage it and know all the bits of management techniques that you can use to help deal with salinity is part of the issue. And I guess that's what this seminar or this webinar is aimed to do.
So you just mentioned it starts sometimes with solidity or in salinity. I don't think everybody's really clear what the difference is. So can you just explain to us, salinity is mainly what?
Well, salinity is mainly the influence of sodium and chloride on the crop development, as we're talking vegetables, usually associated with the water that's being applied. Sodic soils might have been sodic soils forever because they've got a history of high sodium content.
Okay.
Usually there's been a background there where it was under C at one stage. The chloride tends to leach away from the soil profile, but the sodium's there and stays there, particularly in the clay-based soils. So you might have a starting point where the sodium's there, and then you start irrigating with salty water. You've got a double whammy. Okay. So it makes it very difficult to manage.
Yeah, so you can also see in cases where growers do drain soils and saline soils and end up with salinity because the chloride disappears.
Exactly.
And probably another thing is that the EC measurements often is used as an indicator of salinity, which is quite a good indicator, and Julie will talk more about that. However, it doesn't tell you whether it's sodium and chloride. So it's always worthwhile, whatever soil test you do, to have measurements for sodium and measurements for chloride to actually know what you're actually dealing with.
I think that's one of the things, take-home messages from this webinar, is monitor what's going on, get some good information about the quality of the soil, the water and the crop, to try to put that together to come up with a better strategy to deal with the problem.
Yeah,
absolutely.
And I think Julie's going to take us into that zone right now.
You might do that, Julie, and we can always keep discussing things as you go.
As we go along, okay. Absolutely. So in terms of salinity, there is a lot we can do to manage it, but sorry. The here we go. Why isn't it working?
Julie, if you just try and click off that picture to change the slide, we should be right to go.
Yes.
There we go.
Sorry about that, guys. So ultimately, for really good salinity management, we need to know the basics, and a lot of that is to really understand your soils. So what is the distribution of soil types on your property, let alone at the paddock scale. Also the depth of your soil profile and how that may change as well throughout your cropping paddocks. To look at drainage. Drainage is really important to salinity management. So if we have poor drainage, this is where we often get an accumulation of the harmful salts that impact on your crop performance. Irrigation water, as Bruce touched on, understanding the quality of your irrigation water is really, really important. And quite often it's not just testing it once, it's seeing how that may change throughout the seasons. And then also making sure that the crops that we do choose to grow are going to be suitable to grow in those conditions. So when we look at identifying salinity, quite often we walk around the paddocks and we can see where there's an influence. So what you can see on the screen at the moment is a potato crop that is just not, it hasn't germinated because of the salinity.
That's pretty bad.
And you might see instances like this where in the lower lying areas you've got the influence of the salts accumulating and often waterlogging as well, which really prevent plants from germinating or growing and producing healthfully.
Thanks, Julie. That's probably a good point, because often salinity causes poor soil structure. It is often always both is there, isn't it?
Absolutely. So with the poor soil structure, there's minimal airflow, there's poor water uptake, accumulation of salts. It just provides a really nasty environment for young plants to put their roots down and grow. Sometimes we'll actually see the effects of salt where it's evaporating, the water's evaporating, and we're getting salt crystals accumulating on the soil surface within our crops. We might find crops senescing, dying early. They might start kicking off, but then as the season progresses, we might see accumulation of those salts causing issues. Sometimes we get increased diseases in those environments as well, and drainage lines that might be affected by salt.
So do you find that people sometimes misdiagnose it as potassium deficiency or disease? Is that why, does it happen, Bruce?
Oh, that definitely happens, because the symptoms are usually trying to establish the crop when the plants are young, like if they're transplants or seeded crops or spuds going from seed spuds. Getting that crop established if they're in a saline condition is very difficult. And as Julie said, when they get older, they also might start to senesce earlier than expected. So there's a whole lot of symptoms that can appear that may be confused with herbicide damage or nematodes or other things that growers might not expect to see salinity issues. So that's not the first sort of thought in their mind, but actually doing the testing is pretty important to try to understand. One of the beauties that we find with the laboratory work is if we've got a crop that's not performing well and do a SAP test that can be sent to the lab and have the results back in a couple of days, you know exactly what the crop's doing. And that could lead you to the problem of sodium and chloride impacting on the way it's growing.
And that's actually a good point. I remember looking at SAP tests and talking to a colleague actually in Tasmania and saying we have salinity issues, and the answer was no, I'm not in Tasmania. And I said, well, I'm seeing the typical symptoms of high chloride, high sodium, very low potassium, and even though the crops were actually at that stage not very affected, the profile was is a warning sign, isn't it?
Yes, and that idea that the potassium deficiency could be confused is quite right, because the symptom is so similar. Eventually the marginal scorches that are associated with potassium deficiency may indeed show potassium deficiency, but it's being induced by the sodium and chloride problems. Yes.
And of course the water uptake. Water uptake is just hindered by in saline soil. So that's one reason why the plants are really suffering. They're wilting because they cannot take up water. It's
an induced drought condition almost for them, isn't it? So
there's another picture showing symptoms which could be confused with just damage of hail damage or whatever.
So there is a lot to look for, but one of the unfortunate things is that if we're seeing these symptoms in the paddock, it's almost too late. We're getting significant crop losses. Quite often we might have 10% yield reduction, but it's not visible to the eye. So this is where it's really important that we get in there beforehand and we do lots of measurements and understand what we're dealing with so that we can actually manage it, because we can't manage what we don't know.
And that's really something we as people are not good at. We always want to fix stuff later.
That's right.
And I don't think with salinity it's a good idea.
Not a good option. It's once it's there, it's really hard to get rid of, whereas it's much easier to try and prevent. So this is an example of one of the first things we can do is actually look at what risk is present within the area that you're farming in. So this is one example where risk assessment has been mapped for salinity, and you'll see there's pink areas and sort of apricot coloured areas. And those pink areas in particular are quite high risk of developing salinity. So it's not necessarily saying every inch of land in that is affected, but there is a very good risk that you might be affected if you begin cropping in those areas. So most states have this sort of information that's accessible. There's a lot of government websites where maps, etc., can be gained, or talk to your local agronomist even.
If people are interested, we might be able to put a list out through the project about the sites where this kind of information can be found. For instance, this is Tasmanian map. It's very much related to groundwater flow where you get actually natural salinity coming up into the surface. So, and then there's other reasons and there are other maps. So often agronomists and growers don't look for that kind of information, especially when you want to buy land or lease land. This is good stuff to look at.
Absolutely, it's fantastic as a first stop to get a bit of an overview of what you might be facing within the area that you're looking at cropping.
There might also be water monitoring data in. There are some bore locations, and there would be published water.
Absolutely, yep, there is indeed. I think most of the states that I've worked in, you can access groundwater information in terms of either groundwater flow information, where the bores are located, what sort of salinity and pH there is in the bore water, and how it fluctuates over the years. So that information is definitely available too.
Great.
So one of the other things that is very good at identifying potential salt storage in our soils is to use what's called electromagnetic induction surveying. So this is an example of an what's it called, an EM38 map, where the machine passes an electrical signal through the soil profile, generates a secondary signal that's captured. What it does is it gives us an average conductivity within the soil profile, and depending on how it sits on the soil, it can give it over 2 different depths, typically about 50 centimetres or down through to a metre. And the benefit of this is that while it's mapping an apparent conductivity, it's potentially related to waterlogging, soil texture, clay mineralogy, but it also may be salt. So what it does is it gives us a really good spatial picture or awareness of an area that's mapped in terms of where perhaps we may need to focus our attention on. So
where to maybe take the soil test.
Exactly. So we might get these pretty maps. The pretty maps, the really important thing is to understand the scale that they're mapped at. And so you might get 2 different depths, your 50 centimetre and your metre depth, but the actual colour scales might vary for each map. So it's really important to look at your scales. But in particular also, while we may head to an area that's indicating potential salinity, we need to get out there and actually do the test for the spade. There's nothing like a spade to walk around a paddock and really have a look at what we're dealing with.
I'm very fond of the spade, this one knows.
We're very fond of the spade. So a lot of the time it's digging a hole and actually looking at what your soil profile is like. So with the EM induction surveys, it gives us an understanding of whether salinity is uniform throughout the profile, whether it's stratified. Are we looking at salinity that's sitting on the soil surface and it's going to be impacting on our crops now, or is it deeper down in the soil profile and therefore may become a problem if those salts are mobilised and move throughout the system? So if we dig a hole, we can do a lot of this ourselves using a little handheld conductivity meter, which you can see in the picture as well. But the really important thing for that too is that while we can test the conductivity of the water or the soil solution, which is done as you'll see it written as an EC 1 to 5, so it's 1 part soil to 5 parts water, and we can test that using the little handheld conductivity meters. The really important thing there is to make sure that if we want to look at crop tolerance levels, is that we use a conversion factor to multiply our readings in relation to the texture of our soils. So typically if we've got a really sandy soil, there's quite a high conversion factor compared to a clay, which holds a lot more water, therefore it's the conversion factor is a lot lower.
And yes, we have them in our fact sheet. So the fact sheet that Carl announced has got some useful tables in there, and one of them is the conversion factor. And another one is probably also the difference between the EC 1 to 5 and the ECE.
Which is your saturation extract, yes.
And unfortunately, I find the tolerances, crop tolerances, are usually given in as a saturated paste extract, whereas our soil test gives us a 1 to 5 extract, which means really the multiplier is about 10. So you could say, my salinity levels are fine compared to the tables because they're both talking about EC. However, there's about a factor 10 in there. So be careful and use the fact sheet to get it right.
Absolutely, yeah. No, it's really, really important. So in terms of the tolerance table, there are quite a lot of information on the tolerance tables to help us out. So yeah, understanding, digging holes, getting out there and really having a look about is highly important. So the one downside about doing our own soil testing though is that we don't have the ability to differentiate between what the different salts are composed of within our EC 1 to 5 test. It will give us an overall salt content, but if we really want to have a look at what salts we're dealing with, is it sodium, is it chloride, is it magnesium or whatever, we need to actually put it into a lab and find out what that breakdown of salts is. So the other really important thing too is that we need to calibrate these quite regularly and to clean them properly, or else they will give really poor results. But if they are managed well, they will last a long time. But even still, I'd strongly suggest putting some samples through the lab, you know, fairly regularly, just to make sure, you know, what you are testing is correct.
The tolerance tables, I'm surprised because I know that I've seen growers growing lettuce on saline soils, but Boris, you're dealing with it nearly every day. So what's your, just a brief, I mean, we might talk about nutrition a bit more later, but what are, apart from nutrition, what are these people doing?
Like some of the areas that have been dealing with salinity for a long time, such as Werribee South, which is known for very good production of lettuce through the summer months, they have got to manage those crops specifically to deal with the salinity. But there are a whole lot of ways of doing that, and nutrition is obviously a large part of it, but also the irrigation management, whether keeping the soil condition reasonably moist without overwatering and waterlogging the plants is quite important, and trying to keep the salts diluted, but also making sure that the sodium doesn't dominate the root zone, and the sodium and the chloride have a balance with other nutrients to try to take them out of play. So we're used to looking at hydroponic solutions where it's full of useful salts, and when we look at a soil situation, we've got the hydroponic solution basically being fed to the crop in our fertilisers, but there's that background level of sodium and chloride where we've got salinity issues that we've got to take into account, and then we've got to balance those nutrients to try to get everything
so that's something
happy.
Something to look forward to later in this webinar.
Yeah, well, I think, you know, we'll highlight the importance of calcium, because calcium is such a big player in trying to take away the dominance of the sodium.
So before you do all that, you keep actually knowing what you do. So the surface and groundwater testing.
Absolutely. So when we're irrigating our crops, our water supply could come from various sources. It might be groundwater, could be a dam, it might be recycled water, might be shandied out of a river, many different sources. But the really important thing to know is that the quality of that water can vary throughout a year, depending on the season. So sometimes during the summer months, we'll get an accumulation of salts within surface soils within our catchments, and then we get the first rains coming through, and that will flush a lot of those surface salts into our river systems or potentially into dams. So quite often we'll get a spike in salts early on in the season. So it's really important to understand that fluctuation that might be occurring. The likes of bore water, depending on the depth of the bore, where the water's accessed from, that may change as well, or if it's quite deep down, it might be quite stable. So never assume that your irrigation water is going to stay at the same conductivity level. So typically, if you're testing, you know, fairly regularly over at least a 12-month period or over a couple of years, you get to know what that fluctuation and variability is. But I think as we're moving into times when our season's becoming a lot drier and we're getting rainfall at different times, it's probably quite important to make a small investment and do some of your own regular testing for our irrigation water.
And the calibration is important. I found that it was sometimes difficult to get the calibration solution. So it's probably pestering the people who supply the problem.
That's right, and you can buy the calibration solutions to do that. But again, it's making sure that, and it's kept in the right environment as well. So don't have this sitting in the car in the heat and then try and calibrate it. Leave it in the office where it's more stable and do your calibrations there. So,
and Julie, we just had a question come in from Audrey, picking up that point you were talking to just then around measuring and monitoring surface and groundwater. Given the difference in groundwater, Audrey's asking what depth should we base our decision on? And I think that goes back to your point around just seasonal fluctuation and knowing what's happening and a bit of a judgment call. Can you make a bit more of a comment around that?
Yeah, look, I think, I mean, most growers, if they've got their own bore, they know where the depth that it has been installed to. And again, if you know a little bit of the background about the groundwater systems that you're pumping into, that may help determine the likely variability of your groundwater conductivity that's used for irrigation. So, but again, there's nothing like doing your own testing to see what that variability might be, and it might vary from, 500 metres from one hole to another. So again, it is just really important to test. So I would rather test regularly and ensure that you're not going to be putting on some really high levels of salinity to a crop that won't tolerate it.
And I've seen bores that are not that far apart on the same farm have very different water quality.
Yep, absolutely.
Could be helpful.
And I've seen
so not just about depth, it's about location.
It can change quite significantly, yes. So
the next topic is really drainage. So quite often we talk about getting water onto a paddock, but in all cases, but this especially, it's very important to get water off. And one question I actually was going to ask is, the EM38, does it help you with planning for drainage, or is that you need different information?
Look, the EM38 helps in regard to knowing where your heavier and lighter soils are. However, it's the mapping that's done at the time to pick up your levels to help with the accurate drainage. So precision ag can come in really handy here to make sure that we're getting drains in the right position. So, and the other thing is, walking your paddocks in winter, know where the water sits. That can be really helpful too. So if we're putting drains in by eye, we don't always get it right, but there's certainly technology out there now that really helps to put drains in the right position. So, but waterlogging combined with salinity just really exacerbates the salinity issue. So, and at times it's very difficult. We might have an area which we say is internally draining, and you just can't take the water off. But where we can improve drainage, it can make a big difference to crop productivity if we can leach those salts away. They're highly mobile, so we've got that ability to move them out of the soil profile.
So often a wire is the key, isn't it? And not a wire to the next farm.
That's right. Yes, absolutely. So I'm not sure about each state, but sometimes there's whatever comes onto your property, your water that's running off should not be at a higher conductivity. I don't know. The legalities behind that, but it'd certainly be very mindful of where it's heading to. If it's heading straight out into a river system that's not far from the sea, that's not an issue. But if you've got growers downstream that's accessing water, that could become a problem. So sometimes drainage can be really tricky.
So getting help is a good idea.
Absolutely. So, but certainly if crops are improperly drained, it can make a big difference to our crop productivity. So, one of the other things I wanted to touch base on is the use of satellite imagery. So this is, there are many different providers, but there are providers that provide free imagery as well as just basic imagery. What it does is it provides us with an understanding of the vigour, the plant vigour that is growing in the ground. So it's not necessarily telling us that there's salt, but it might help to indicate across a number of paddocks, if you're in an area prone to salinity, where some of the hotspots might be, because quite often these end-of-the-eye maps will correlate with your EM38 data.
So then you don't have to dig up the whole paddock, you can go.
This really helps to target where you're going.
Yep.
So the EM38 provides a real baseline information that's not likely to change a lot, but this may change a little bit more depending on the seasons. So it's
a good tool.
Information about a very, very helpful tool. So yeah.
And probably it's interesting if you plan to grow a high value crop to actually look at satellite imaging from the previous crop.
Oh, absolutely. Yeah. Satellite imagery, if you can go back in years and look at how the crops have performed, but equally Google imagery.
Yeah, that's actually
can be really, really
you
helpful.
Do historic stuff. Yep.
Yeah, you can go back in time and look at how the product how your paddock has performed for many, many years. And
yeah, I find that really good. Yeah.
Sometimes it's, with change, we've got road infrastructure that's changed or dams that have changed location. So it might be an area of a paddock that's extremely waterlogged and you're thinking why, but if you can go back on the aerial imagery, it can give you a really good understanding of the paddock history. So yeah,
but many people don't know, but Google Earth does it. Yep.
Oh, it's phenomenal. It is very, very, very good. So when we're testing our soils, one of the things that's been probably an issue between specialists for many, many years is understanding the units of measurement. And what we often find is that different labs will report in different units, or different researchers might provide their information in different units.
Or don't have units at all.
Or don't have units at all, they just call them ECs.
Yeah.
And it makes it very, very hard to understand what we're dealing with if we don't know the units that we're dealing with. So this information is in the handout, but commonly, one of the most commonly used units is the decisiemens per metre. It's fairly good for water and soils at a broad range. But in terms of understanding how they join up, so the likes of an EM38 map, that's often reported in millisiemens per metre. Sometimes water is in microsiemens per centimetre. Make sure when you're having a look at your data, or if you're getting reports coming in from the lab, just make sure you understand what units you're dealing with, because it can make a big difference. So, but I think most of the crop tolerance tables are reported in decisiemens per metre as well.
If they are not from the US, there could be anything. We should use local data.
Yeah, so just a heads up in that it is quite important to know what we're dealing with.
So that's from the fact sheet as well, isn't it? A table of
correct
classes.
Yes.
So that's a good thing to have on hand.
Yep, and this might vary from one state to another, but it's a fairly common range in terms of when we're looking at a salinity level for irrigation water or for soil. These are the broad classifications that we often use. So typically, if we've got low to medium, we can irrigate most crops on most soils, but we might find that if we start irrigating with anything, say around the 1 decisiemen per metre on a heavy soil, that might make a big difference. So I think taking me back a number of years, for every 1 decisiemen, or for every megalitre of water applied per hectare at 1 decisiemen per metre, we're looking at about 600 kilos of salt that's applied. So that gives you a little bit of an understanding in terms of where we sit with these classes and how much salt we're potentially applying to our soils, and therefore the real importance of drainage and understanding our soils.
Yeah, Julie, I reckon we do see quite a lot of examples where the sodium level and the chloride level that make up those salts that you're talking about in those could be around 200 parts per million each. So we would often say to a grower that a megalitre of that water is going to apply 200 kilos of sodium per hectare. Most growers don't put on 200 kilos of nitrogen or 200 kilos of potassium. So just gives you an indication of how severe some of the salty water applications can be for the long-term health of the soil and the crops.
Absolutely.
So it might be worthwhile, we soon get to actually because you put on X kilograms of salt, it would be good to know what you actually do with the management.
Yes, how can you balance that with the other inputs to try to make sure that the salt doesn't dominate the whole scenario?
Yeah, so one reasonably simple aspect is to look after soil structure in any way you can, reduce tillage, try and cover crops. I've done some work with good compost, not rotting stuff, but good compost. And probably the main effect of a good compost would be drainage. So it's all about drainage and then nutrition. Yeah, and knowing. So do you want to talk a little bit about nutrition?
Well, I guess what we're trying to do is do all the positives and reduce the negatives. We've already got a really big negative with the saline water that we might be applying, or the conditions of the soil at the moment. So how do we get to overcome that? What can you do? A lot of people with sodic soils or in a salinity situation are going to think of gypsum. Gypsum is one means of trying to change the chemical nature of the soil and to get that better drainage and better aeration, but there are a lot of other things that you can do. And chemically, one of the moves that we've made in some of the areas that are most badly affected with salinity is to make sure we're increasing calcium in other ways. Gypsum is a long-term effect. For the short-term benefit of the crop that's in the ground, that you've identified a problem you're going to try to deal with. Calcium nitrate gives you a calcium product that's immediately available and going to have an impact on the soil and help to minimise the effect of the sodium. The nitrate is a better way to go than the ammonium. If you've got a salt problem, the ammonium is only antagonising the situation. So the nitrate forms of fertiliser are preferable. Try to avoid any chloride applications, obviously. So muriate of potash is something that we would take out of the equation.
Definitely then.
Trying to spoon feed the crop. So where you've got fertigation opportunities, that's a much better way to be able to handle the salinity and deal with it on a weekly or daily basis. So that you've got some sort of way of suppressing the sodium and the chloride.
So it is a hydroponics solution you're having there?
Pretty much, because you've got a solution of salt water, basically, that you've got to try to ameliorate or balance. In some ways we can't really ameliorate it, we've got to balance it. And under the current conditions in a lot of areas that are dealing with drought, there's no quick answer to the problem. The saline water is going to be used continually through the growth of the crops, and there'll be a big build-up, as we said before, of sodium. Some chloride is going on all the time and it's going to leach, but you're continually putting it on, so you've continually got that problem to deal with. So coming up with a program of fertiliser applications that's better aimed at that specific salinity problem is really important.
Yes, so again, knowing everything that Julie has talked about beforehand and looking at these signs and tolerance tables, it's worth checking, I guess, even though people seem to grow lettuce invariably, which is astounding. However, they learned over time how to do it. So you wouldn't probably not start with this, would you?
It can be difficult, especially establishing crops from seed where you've got salty water. Most crops find it very difficult in that germination stage to deal with the salt. So finding crops that can handle that is quite difficult. So if you've got a choice of waters, preferably we'd be saying use your better quality water to establish the crop. And if you have to use the salty water a little bit later or shandy that salty water, so be it. But the way that you use the salty water that you've got at your disposal, if you've got any better quality water, try to use that wisely in the management of the crop. Potassium, a lot of soils can have quite a high level of potassium. The Gatton area, for example, most of the soils have got quite good potassium levels, but when salt starts to dominate and sodium starts to dominate, the sodium competes very heavily with potassium. So you may indeed need a higher level of potassium inputs to deal with.
I remember having an argument with some growers on these.
We don't need potassium. Well, I'm afraid you do if the salinity is causing you the problem of not being able to get the potassium uptake.
And the SAP test shows it.
So the SAP test is a great way of dealing with a current crop that's showing you some problems, and you're maybe not really sure how serious the salinity is because you haven't done all the previous groundwork. SAP testing and soil root zone monitoring can be a really good way of finding out what the extent of the problem is and whether your current fertiliser program or management system is helping to deal with it or it's antagonising it. So a series of sap testing through that crop that's currently causing you some problems could be a great way to get a better result in the crops that are still to come. The soil solution monitoring matches the sap uptake very closely.
So you've done quite a bit of work on that.
Yes, yeah. So there's a lot of information you can gather. Walking the crops is a good thing, obviously, and getting the spade out, as we talked about before. One of the most obvious symptoms that we've seen where salinity has been a big problem is the variation in the crop.
Oh, yep, and that's clear from the pictures that
Julie showed those pictures earlier on. The crop is all over the place. Some good plants, some stunted to the point that they're almost non-existent. Really variable growth in the crop. Often indicative, particularly where you've got sprinkler irrigation or pivots and that sort of thing, where the watering may not be completely even, indicative of the influence of the amount of water that's being applied as well, and how quickly the soil's drying out and concentrating the salts back around the root zone.
So the drainage is, apart from good irrigation management, probably vital.
Yes, those two things together, the irrigation quantity and quality and the drainage, they're sort of crucial to being able to put the water on and also to deal with the getting rid of the salt problem.
And for your inputs to work, so obviously the inputs are high quality inputs. You want them to work.
Yes.
On the whole crop.
With the fertiliser program, we're going to be moving to fairly higher class inputs, very similar to what we would be using in hydroponics.
Yes.
Where we want the absolute uptake of the nutrients and no uptake of something that's going to be detrimental. If you've got saline water conditions, you're just trying to minimise the uptake of the salt with the sodium and the chloride.
Yeah, so that makes sense. So just checking, maybe you put some key points up, Julie, just so we can see whether we forgot anything.
Yeah, so some of the key points are conditions change. We know that from one day to another, might be from one season to another, but the key point is to really make sure we test and test regularly to understand what those variabilities might be. Soils can accumulate salt over time. So it depends, like the variability of crop growth in the paddock could be in relation to the underlying clay impermeable layer. You know, we often find that will vary as well and can make a big difference. Recycled water, know what nutrients you're putting on.
And it changes in quality as well.
Absolutely.
The recycled water can be a problem where the water's being heavily chlorinated. So if it's coming from a suburban system or a city system, just be very careful that the chloride level may change dramatically through the season, depending on what's going through the system and how much amelioration of the quality of the water the water treatment plant is doing.
So is that, do you find a seasonal difference?
It is a seasonal difference,
in summer it's worse or in winter?
Yeah, look, it will vary, probably not as bad in winter, and maybe we're not having to irrigate as heavily in winter, that's part of the issue. But in general, the chlorination will probably be heavier during the summer months. So good. Just be careful of chlorine.
The other thing to consider there too is that depending on the size of your dam, we can get stratification of salt within the water profile too. So sometimes where we draw the water from, near the surface or close to the bottom, can make an impact on the quality of the water that we're applying.
And often the water gives you an indication itself. If it's sitting in a dam and the water's very clear, it's often a pretty bad sign. You might think it's good quality water, but it's often because it's very salty.
Or if it's very cloudy, it's salty.
Yes.
So certainly know your enemy is a good slogan there.
Absolutely.
And there are a lot of visuals that can help you out as well as the testing. Just knowing your crops and knowing the water and knowing the soil, as we said before.
Absolutely. And so knowing our crops, understanding how tolerant your crop might be or how sensitive it is to the salt level. So there are some that are incredibly sensitive to salts, the sodium and the chloride, and there are others that are a lot more tolerant and can cope with those conditions more. But as Bruce alluded to before as well, it's getting a young plant or a seed to germinate in saline conditions that are a lot more sensitive than the actual, the more advanced plants as well. So The tolerance tables are available,
Yeah.
and I suppose the other key thing behind that is where we talked about the EC 1 to 5 that you might test for yourself or get back from a lab, is to make sure that you do your soil texturing and apply the appropriate conversion so that we've got a better understanding of the accurate crop tolerances.
And I guess looking at inputs like we mentioned, gypsum, some can be salty. So make sure you know the quality of the gypsum, and some compost can be salty.
Absolutely.
So we need to be careful with the inputs as well.
What we're putting on.
One of the alternatives to gypsum that we've had a lot of success with over the past few years has been calcium thiosulfate.
Yes.
So it's basically got the same properties, having calcium and sulfur, but in a true solution. So that's another piece of armoury that you've got to help with the management. And it's been widely used around the country for that purpose.
Soluble calcium product.
Yeah.
Without the nitrogen.
Yeah. I think one of the other things is that we're learning a lot from existing crops being grown with salinity issues in areas that's been for quite a long time, such as Werribee South, and being able to transfer that information to other areas where maybe vegetable production is relatively new or hasn't had the salinity issues, to try to spread some helpful information to give growers some of the options that are available.
Just one question, Julie, you work a lot with cover crops, which I know. Do you think that cover crops help or get that badly affected? Or
cover crops can be really beneficial for improving your soil structure.
Okay, that's the challenge.
You also get beneficial advantage of helping to build the natural soil microbial composition as well. A lot of it's all to do with the soil structure.
Okay.
So if we can get a crop growing that is tolerant to the conditions and have that in place for a while, it does really help to improve aeration and improve drainage. So if we're putting the water on, we can try and leach those salts further down. And the opposite of that is if we leave a paddock fallow, what we're doing is we're opening up the soils to a lot of evaporation. And as the water evaporates, it carries a lot of the salts to the soil surface. So I've actually seen a paddock that was under pasture be sprayed off ready for a crop, and just in one season it was too saline to plant a crop. So quite often we don't get changes that quickly, but I have seen it. So again, if we do the testing ahead of time and get a heads up before we make some major changes, it can make a big difference to our management.
I think it might be a good idea to do your last, just finish the key points. Important is, you said talk to your agronomist, make sure your agronomist understands salinity.
Absolutely.
Because not everybody does.
No, not everyone does. And quite often people might not assume that they're in a saline area to start with. So I know here in Tassie, when many years ago, general knowledge across Australia, everyone said, well, what are you trying to do? We don't have salt. And I think that was going back in the days when I was doing the mapping and you were looking at the SAP analysis, and it was like, no, we do have some issues here that we need to manage. So really understanding what we're dealing with makes it's quite important. So Bruce has talked a little bit about irrigation and volumes of water that we can put on, but some of the other things as we're moving into very hot, windy conditions is to be mindful of when we're applying irrigation water. If we've got the ability not to irrigate on a hot, windy day, for instance, we might get increased scorching of leaves, higher evaporation rates, for instance.
It becomes really difficult under pivot to deal with that under certain soil conditions. So, it can be very difficult to manage that one. And then you end up with a paddock showing quite a bit of variability related to salinity, but also related to water.
That's right. So variable rate application of our irrigation water can be really beneficial because it gives us the ability to apply water where it's needed more. And less perhaps in the heavier soils where the salts are accumulating. So VRI, if it's possible, can be very, very good, as is most precision ag techniques. They help with reducing compaction and all sorts of things. So,
So we probably have covered the most of it. So Carl, if you're happy to invite questions, we have a little bit of time left. There might be some questions.
Absolutely. No, thanks very much, Doris, Bruce and Julie. That's been fantastic and a really good way of presenting the information in a discussion-based format with lots of pictures and not too much content up on the screen. I think that's been really beneficial. Please make sure if you do have a question as a result of that, I know I do, and while we're waiting for those to come through and typed into the question bar, I just might put one to the panel. You talked a lot about the importance of building organic matter in soils and improving that overall system resilience, but also other ameliorants like gypsum. The importance of those being really good quality. How do you know that what you're using is good quality? What are some of the kind of key questions you should be asking suppliers of those products and things you should be looking out for?
Well, I would be definitely asking for an analysis of the compost, and not one from 2 years back or 10 years back, but really I would want to know the current batch analysis. And I've seen growers showing me an analysis and saying, "Oh, do you think I should use that?" And I look at it and said, they didn't give you the EC. So I think maybe they're hiding something. So you just, the good compost producers will give you the right information. So they have got other reasons than salinity to have proper information on what you're putting on. The same with gypsum. There are analysis of gypsum that I've seen some, especially from Victoria, that I wouldn't want to put on my paddock.
I think it's important, Carl, that we would say that you don't put anything on that you don't know what it contains. So you don't want to be putting on products that might be adding to the salt problem, and some things like cattle stockyards and things like that, they can be quite salty and cause a lot more damage than the good they're going to do. So yeah, it's worth knowing what the quality and potential salinity component of any of the additions you're going to be putting on that might be adverse to the whole issue. There are a lot of good things you can be using, so yeah, knowing which are the good ones and which aren't is really important. And that information is found out by getting the test results and being able to analyse what's been given to you to decide whether you should or you shouldn't put it on the paddock. Whether the grower knows how to do it or the agronomist knows how to do it, somebody needs to be able to read that information.
Sometimes transport compost can be quite expensive too, depending on the locality of suppliers, and perhaps that's where growers might want to consider putting in a short cover crop.
Yes, definitely.
You know, I know it's really awkward with a lot of the vegetable producing areas because it's you know, very timely to get one crop in after another, but even just a few weeks of growing a crop can provide a lot of good exudates and organic matter to the soil.
And some are pretty quick, some of the grains, grasses, the buckwheat.
Oh yeah, exceptionally quick.
And a bit of a break in the whole procedure could be useful because, as we said before, if you're constantly putting on megalitres of water that is high in sodium and chloride, it's a never-ending cycle. If you can break that cycle somehow, where the cover crop might be able to grow with a limited amount of water, that can help to limit the amount of salt that's being applied.
So over the season, that might be still the more profitable option.
Yes, it might be better than continually going on with salty water.
And you're getting the other benefits of a cover crop too in breaking things like disease cycle, not just application of salts, which is a good thing too. Bruce, you mentioned before, you know, irrigation and the role of soil moisture monitoring and root zone monitoring. I'm just interested in a couple of tips around, you know, how do you make sure you do that properly?
One of the tools that is available that we've been using is a soil solution monitoring tool. Centex sell one called a Solu sampler. There are others around that can be used. You create a vacuum, you pull the sample from the root zone, so you're getting an indication of what is floating around the roots in the soil solution when you irrigate, and that can give you a really good handle on just what the balance is between the sodium and the chloride and the other nutrients, so that whether you're putting your fertiliser nutrients into the root zone or whether you're washing them down below and leaving what's around the root zone to the salt you can get a better handle on what your irrigation management is doing to either create a problem or help lessen the problem with the salinity. So, yeah.
And they're fairly well priced, so aren't they?
Yes, it's quite worthwhile doing. The whole idea of sap testing, so you've got a really good handle on what the plant is taking up, given the water quality that you're using, and comparing that to the soil solution in the root zone is pretty useful, because those two things mimic each other very well, a lot more than the soil test.
Probably also, if you want to use soil moisture monitoring equipment, get a NDVI or an E30, get a map to see how variable the paddock is, because if you put it in the wrong place, you will get really bad information, and yeah, it's a waste of time and money.
That's right.
And if you use capacitance probes, make sure they're calibrated properly, because different soil textures give you a different result, because they measure water content. So 20% in the sand is nothing, and 20% in the clay might be all right. So it's really important to actually get really good information on the monitoring gear and understand what it actually does, and not just get some kind of wiggly lines.
So, and the capacitance probes, I mean, they're a little bit more expensive as well. So again, if you want to make sure you're putting it in the right place, you need all the background information. One of the other tools that I've used as well is a little Field Scout soil moisture probe. So it's got prongs that are about 20 centimetres long, and it actually gives us the ability to walk all over a paddock,
nice.
and it will store hundreds and hundreds of readings. So it is just a straight conductivity, decimeter per metre, but it will give you that variability across a paddock as a good starting point. So that's another option for people to consider.
In the spine.
We've had a question, sorry Doris, so just conscious of time, we've got quite a few questions just to get to. We've had one coming from John. He's made the comment, I've heard from a farm with very serious salt problems that claims the key for them is to never stop irrigating. As long as they irrigate, they say the salts are kept at bay, and he's just wondering if anyone can comment on that particular management technique.
Well, draining soils?
Yeah, look, I think we were saying before that if you let the soil dry out between irrigations, for instance, in general, that's going to concentrate the salts back around the root zone. So keeping consistent soil moisture is one of the ways that we would deal with problems of salinity, depending on the soil type of it, Julie, obviously, but trying to avoid the boom and bust scenario with water is quite important. So depending on your soil type, it's probably relatively true that keeping the water up to the crop rather than letting it dry out in between irrigations is important. We don't want to waterlog the crop, so it's important not to overdo the watering, but if you're doing consistent watering to try to keep the soil moisture content at an optimum level, that's highly desirable.
We found in compacted soils, and often saline soils are also compacted, you have to be very careful with the amount of water, because you imagine it's compacted, so there's not much drainage and not much space to actually hold water. So it's very easy, and I've seen a lot of data where people over irrigate. So while what Bruce is right, people have to be really careful to get it right.
So if you've got really heavy impermeable clays, we can actually create water, little perch water tables, which eventually, depending on the height, the plants might be putting their roots in.
Where plants are grown on beds, often we can only make that bed successful, and what's going on in between, that's just, we'll have to deal with that later. But in the current crop, if you can keep the root zone, which may be that bedded up area, as free of salt as possible, so you're leaching it through to drain away below there, that can help get the crop through.
And that's probably the difference. Like if you have a deep rooting crop, you have more problems.
So in general, we're getting rid of that compacted layer by working with that bed. There might be a compacted layer down below, but you can manage that to some degree in the current crop.
So you end up having a hydroponic system on top of everything else.
There might be crap underneath, but it doesn't really matter.
So don't dig it up.
Don't dig it up. That can be a bad mistake.
So look, on that note of not digging it up, I think that's been a really fantastic discussion. Doris, Bruce and Julie, thank you very much for your time. That's been fantastic. Thanks too to those questions that have come through from everyone on the line as well. Just in closing, we do have more tips and tools available here to take away from the webinar. It is being recorded and we can distribute that to you shortly. But on the Soil Wealth website, there's the host of fact sheets, some global scans, past webinar recordings and other videos to refer to. We specifically mentioned the salinity fact sheet that we've been mentioning throughout this session. That's available for download on your handouts tab to take away with you and refer back to. All the content's been covered in this discussion, which is great. And some of those earlier resources that Julie mentioned, the mapping resources by state, there's a couple of examples on your screen now. Ag Insight from South Australia and List Map from Tasmania as well. So follow those links and have a bit of an explore around. If you are in different states, there'll be the equivalent there too. But look, I think some key take homes from that for me, salinity is common but can be managed, and just the importance of monitoring. I think building that organic matter is vital around building soil structure and broader system resilience, and the importance of looking at water on through irrigation and water off through drainage, making sure you're getting that balance right. So look, thank you very much to the presenters again, and thank you for joining us, and we'll see you next time at the Soil Wealth ICP webinar that we run in the future. Thanks everyone.
Thank you.
Thank you.